Welcome to English Insights. And today, we'll improve your English while exploring machine learning, the technology powering smart assistants, self-driving cars, and more. Let's dive in, practice English, and uncover how machines are transforming our world.
All right, strap in, everybody. Today, we're taking a deep dive into machine learning.
Sounds pretty futuristic, right?
Yeah, like straight out of sci-fi. But it's already all around us.
Exactly. It's about algorithms, they can actually learn and adapt.
So instead of hard-coding rules into a computer, we're teaching it to learn, like we do.
Yeah, that's a great way to think about it. We call it machine learning, or ML, creating algorithms that can go through tons of data, find patterns, and then make predictions.
Okay, so algorithms. But what exactly is a machine learning algorithm? Is it some crazy, complicated math equation, or what?
Kinda, yeah. At its core, it's a set of instructions for a computer to process data, right? But the cool part is these instructions can actually change. Based on the data, they're constantly getting refined.
So it's like the algorithm is always learning and evolving, getting smarter over time.
Exactly, and that's what makes machine learning so powerful. Computers doing things that before we thought only humans could do.
This is blowing my mind a little bit. I knew machine learning was a big deal, but I didn't realize how much it was already impacting things.
It really is. Tons of industries. Healthcare, finance, transportation, entertainment, you name it. And it's just getting started.
Okay, now I'm really curious. Give me some real-world examples. Where are we seeing machine learning in action right now?
Well, think about when you're streaming on Netflix or shopping online. Those recommendations you see, the ones that seem to know what you like,
Yeah.
That's machine learning.
Whoa, I never connected those dots.
Yeah.
So it's analyzing my watch history, my purchases, to figure out what I'd want.
Exactly, and it goes way beyond that. Machine learning is even helping doctors diagnose diseases.
Really?
Yep, they can analyze medical images, patient data, catch things earlier,
So it's like having another doctor in the room, but a super-powered one who can spot things even experts might miss.
You got it. And the potential for patients is huge. The earlier you catch something, the better the chances are.
This is making me think about all the good that can come from this. But I know it can't be all sunshine and roses. What are the challenges, the downsides?
You're right, no technology is perfect. And with machine learning, a big one is making sure it's used responsibly.
What do you mean responsibly?
Well, think about the data used to train these algorithms. If it's biased, incomplete, the algorithm is going to inherit that bias, right? Could lead to unfair outcomes.
That's a huge point. So it's not just the tech itself, it's the data and how we choose to use it.
Absolutely. We have to be having these conversations about the ethics of machine learning. Make sure it benefits everyone, not just a select few.
Okay, responsible development and ethical stuff, check. What other challenges are out there?
Another big one is what we call the black box problem. Sometimes with these complex models, it's hard to know how it came to a decision.
So it's making decisions, but we don't know why or how. That's kind of unsettling.
Yeah, it's a valid concern. But researchers are working on it, trying to make these models more transparent. It's a whole field called explainable AI.
So the more we understand how it works, the better we can trust it and use it the right way.
Exactly. And as this tech keeps evolving, we all need to stay informed. This has the potential to shape the future in a big way, and it's up to us to make sure it's a good future.
Okay, I'm feeling the responsibility here. But I gotta admit, I'm still a bit hazy on the types of machine learning. It's not all just one thing, right?
You're right. There are different approaches. Think of it like different ways a machine can learn from data.
The learning taxonomy. Okay, color me intrigued. Let's start with what's supervised learning.
In supervised learning, we give the algorithm labeled data. So it gets the input and the desired output. Imagine giving a student practice problems with the answers.
So it's learning by example, figuring out how the input and output are connected.
Exactly. And once it's got that relationship, then it can make predictions on brand new data.
Like training it to spot patterns, then using that to solve new problems.
Exactly. And this is used all over the place. Image recognition, spam filters, medical diagnosis, financial stuff, you name it. So versatile. What about unsupervised learning? How's that different?
This time, the algorithm gets unlabeled data, no answers provided. Like giving a student a puzzle with no picture on the box.
So it's on its own, no guidance.
Exactly. It has to explore the data, find the patterns, group similar things together without any categories given beforehand.
That sounds way harder. What can it even learn from that?
Well, one thing is clustering, grouping similar data points together based on their characteristics, like grouping customers based on their shopping habits.
So instead of us telling it how to group them, it figures it out from the data itself.
That's the idea. And it can also be used for anomaly detection, finding the things that are unusual that don't fit the normal pattern.
Okay, that's super helpful, especially when you don't know what you're looking for. So we've got supervised and unsupervised. Now what about reinforcement learning? That one sounds kind of mysterious.
This one's about training an algorithm to make decisions in a changing environment. Like, think about training a dog.
You reward good behavior, discourage bad behavior. Over time, the dog learns to do what you want.
Ah, I see where you're going with this. So the algorithm's the dog, learning by trial and error, getting rewards or penalties.
You got it. And this type is really good for tasks with sequential decision-making, like playing games, controlling robots.
So it's always learning and changing its strategy based on how well it's doing.
Exactly. Makes it great for AI systems that have to operate on their own in complex situations.
Okay, I think I'm starting to wrap my head around these different types. It's wild how many approaches there are.
It's a crazy, fast-moving field. We're just scratching the surface here.
I can't wait to see what comes next. But for now, I think we've covered a lot of ground in this first part of our deep dive into machine learning.
We have. What is machine learning, how it works, some examples of it out in the world. We even touched on some of the challenges, those ethical questions we got to think about.
And we learned about the big three types of machine learning: supervised, unsupervised, reinforcement, each with its own way of learning from data.
Stay tuned for part 2. We're going to go even deeper. More about the algorithms, the cool stuff that's pushing this field forward, and some of the most exciting ways this is all being applied.
Keep those learning gears turning, everybody.
We'll be back soon. Welcome back to our deep dive on machine learning.
Ready to go deeper? Last time we were talking about how machines learn, supervised, unsupervised, reinforcement, the whole thing. It's crazy how those algorithms pick up patterns, make predictions, almost like they're, I don't know, thinking.
It really is impressive, but it's good to remember there's still tools, right? Made by humans to solve problems.
True. Easy to get carried away and think of AI as magic, but it's all human ingenuity in the end.
Exactly. And speaking of ingenuity, the algorithms themselves, that's decades of research development, all these techniques, approaches. It's fascinating.
All right, lay it on me. Algorithm time. What are some of the stars of the machine learning show?
Oh, there are so many. Each one's got its own thing it's good at, you know? But let's start simple. One of the most popular, versatile ones out there is called the decision tree.
A decision tree. That sounds kind of basic for something as complex as machine learning.
It might sound basic, but it's powerful. Imagine a tree, right? The branches are decisions, choices, and each branch leads to more branches, narrowing down the possibilities until you get to the final answer, the prediction.
Okay, I can kind of picture that. But how does this tree actually learn from the data?
So the algorithm goes through the data, looks for the best way to split it into groups based on the features of each data point. Like, say you're trying to predict if someone will buy a product. You might start by splitting based on their age, how much money they make, or what they've bought before.
So it's asking questions like, are they over 30? Or do they have a high income? And using the answers to go down the right path on the tree.
That's it. And every time it splits, it's choosing the feature that gives the most information, you know, the one that separates the data into groups that are as different as possible in terms of the outcome you're trying to predict.
So the tree is always learning, refining its decisions, getting more accurate as it goes.
Yep. And the cool thing about decision trees is they're easy to understand. Even if you're not super technical, you can see the tree, how it's making its decisions.
That's super important, especially for things like, I don't know, medical stuff, financial predictions.
Yeah.
You got to be able to see the logic, why the algorithm said what it said.
For sure. That's why they're used in places where transparency is key.
Okay, decision trees, got it. What else is in the machine learning toolbox?
Another one is called the support vector machine, SVM for short. A bit more complex, but the idea is to separate data points into categories using, get this, a hyperplane.
A hyperplane. Sounds like something out of Star Trek. Break that down for me.
All right, picture this. You've got a bunch of data points on a graph, right? Some belong to one group, some to another. The SVM tries to find the line, or in higher dimensions, the hyperplane, that splits them the best. A clear boundary between the categories.
Like drawing a line in the sand. Sheep on one side, goats on the other.
Huh, that's the idea. And it wants to find the line that maximizes the margin, the space between the line, and the closest points from each group. Make sure the model works well, even when it sees brand new data it's never seen before.
So it's not just about separating. It's about separating in a way that's really robust.
Exactly. And SVMs, they're awesome for high-dimensional data with a ton of features. Image recognition, text stuff, even bioinformatics, they're used everywhere.
Okay, definitely more complex than decision trees, but starting to get it. What other algorithmic tricks are up machine learning's sleeve?
All right, now for the big one, neural networks. They've been all over the news, and for good reason. They're super powerful, super versatile, can do some crazy, complex stuff.
Neural networks. Sounds like, I don't know, the human brain or something. Is there a connection there?
You're closer than you think. Neural networks, they're actually inspired by how our brains work. Lots of interconnected nodes, think of them like artificial neurons. Processing information, passing it along to the next layer.
So it's like a whole chain of calculations, each layer building on the one before it.
That's a great way to put it. And by changing the connections between these neurons, tweaking how much each one matters, the network can learn to recognize patterns, make predictions based on what you feed it.
I can see how that would be powerful, but how does a neural network actually learn?
You feed it labeled data, and it adjusts those connections between neurons, trying to get its predictions closer and closer to the actual answers.
So it's always adjusting itself, trying to get better and better.
Exactly, and this can happen millions of times. The network keeps getting more accurate, more sophisticated at spotting patterns, making those predictions.
Sounds like it takes a lot of computer power.
It can, yeah. Training a big neural network, that's a lot of data, a lot of processing. But the results are incredible.
I've heard about them being used for everything. Self-driving cars, language stuff. What are the most exciting things happening with neural networks?
One of the biggest is computer vision. They're powering facial recognition, spotting objects in images and videos, even creating realistic images from scratch.
Whoa, so we're getting to the point where machines can actually see the world, understand it like we do.
We're getting there. Another huge area is natural language processing, or NLP. Translation, text generation, understanding spoken language, even figuring out the sentiment, the emotion behind what someone's saying.
Hold on. So machines can see and understand us, talk back to us. That's wild.
It's an amazing time for AI. So much happening, so fast, and so many possibilities.
I'm feeling a mix of like excitement and a little bit of, I don't know, apprehension. It's both cool and a little scary to think about.
I get it. We got to be excited about the potential, but also cautious, you know?
Absolutely. We need to talk about the ethical side of all this. Make sure it's being developed, used for good.
Couldn't agree more. And that's why these conversations are so important.
All right, feeling the weight of responsibility here. But I'm hooked, man. Can't wait to see where this goes.
Me too. Machine learning, the future's wide open.
Well, this deep dive has been amazing. I feel like I've barely scratched the surface, but I want to know more.
That's what we like to hear. And guess what? We're not done yet.
Okay, part 3. What's next?
We're shifting gears a bit. Time to see machine learning out in the wild, how it's changing industries, transforming things. Medicine, transportation, even tackling some of the world's biggest problems.
I'm all in. Can't wait. Welcome back to the deep dive. We spent the last 2 parts really getting into the nuts and bolts of machine learning, algorithms, the different ways machines can learn.
It's been a good foundation because now we get to see it all in action.
Exactly. It's like we learn the alphabet, the grammar, and now story time.
I like that. Okay, so let's start with something everyone cares about, healthcare.
Everyone wants to be healthy, so yeah, that's definitely relevant.
Machine learning is already doing a lot in healthcare, improving diagnosis, personalizing treatments, all sorts of stuff.
When you say personalized medicine, what's that actually look like?
Imagine treatments tailored to you specifically. Your genes, your lifestyle, your whole medical history.
That sounds so futuristic. How does machine learning even make that possible?
Data, tons of it. Your DNA, your medical records, even data from those wearable health trackers. Algorithms can find the patterns in all that, predict your health risks, how you'll respond to treatments.
So it's like a virtual health advisor that knows you better than you know yourself.
You could say that. It's moving away from that one-size-fits-all approach to medicine. More targeted, more effective.
It's incredible. It's like those medical dramas where the doctors are trying to figure out what's wrong. This could make diagnosis so much faster, more accurate.
Absolutely. They're already using it to look at medical images, x-rays, CT scans, helping doctors spot things that might be easy to miss.
That's a big deal, especially for things where catching it early is so important.
And it goes beyond just diagnosis. Optimizing treatment plans, too, like predicting who's most likely to benefit from a certain drug or therapy.
So less guesswork, more precision in the treatment.
That's the goal, getting the most out of treatments with fewer side effects.
Okay, so healthcare, huge impact. What other industries are being transformed by machine learning?
Let's talk transportation. Self-driving cars, that's probably the most obvious example right now.
They're always in the news, but still feel kind of sci-fi, you know?
They're getting closer every day.
Yeah.
And machine learning, that's the brains of the operation.
So how does machine learning actually make a car drive itself?
Okay, so self-driving cars, they've got all these sensors, cameras, LiDAR, radar, tons of stuff, collecting data about what's around them. And those machine learning algorithms, they're processing all that data, making decisions in real time, steering, braking, accelerating.
Like a superpowered driver who can see everything, react instantly.
Exactly. And think about the potential: fewer accidents, smoother traffic, maybe we even get some of our time back during commutes.
I can definitely get behind that.
Yeah.
But are they really safe? It feels like I always hear about self-driving car accidents.
Safety is super important, yeah. And there have been some incidents, yeah, but statistically, they're already safer than human drivers.
Really? That's surprising. I mean, it's still pretty new tech.
That's the thing. They don't get tired. They don't get distracted. They don't make emotional decisions. They're just constantly analyzing, making judgments based on the data.
So it's not about, like, removing human error completely. It's about minimizing it, using data and algorithms.
Exactly. And as it keeps developing, it's only going to get safer.
Okay, starting to come around on the whole self-driving thing. So beyond healthcare, transportation, what else is machine learning doing?
It's being used to tackle some of the biggest problems we face: climate change, poverty, you name it.
That's amazing. So it's not just about convenience, it's about doing good.
For sure. It's being used to optimize renewable energy systems, making them more efficient, more affordable.
Helping us move to a more sustainable future.
Playing a key role, yeah. And it's also helping with disaster response, predicting disease outbreaks, even personalizing education.
The possibilities really are endless. It feels like we're at the start of something huge. Using machine learning to solve problems that have been around forever.
It's a powerful tool, and it's up to us to use it wisely.
That's a good point. We've talked a lot about the good stuff, but it's not a magic solution. We have to think about the risks, the challenges, like bias in algorithms, the impact on jobs.
All important stuff to consider. We're still figuring it all out, you know?
It's a journey, for sure.
It is. Machine learning, it's always evolving. The future's wide open.
This has been such an incredible deep dive. I've learned so much. I'm honestly a little blown away by what this tech can do.
It's been great talking about all this with you. And hey, the learning doesn't stop here.
To everyone listening, keep digging into machine learning. It's changing the world. And who knows, maybe you'll be part of making the next big breakthrough.
Stay curious. Stay informed.
It's time to wrap up this episode of The Deep Dive. Until next time, keep exploring, keep learning, and keep diving deep.
Thank you for joining us in this episode on machine learning. We hope you enjoyed exploring the fascinating world of algorithms and data-driven insights. If you found this content valuable, don't forget to subscribe and stay updated on future episodes. Share this with friends who love tech and innovation, and let's keep learning together. See you next time.